Good day, grade 10 students, and welcome to another episode of the grade 10 Geography Cap series. We are still continuing on, guys, with our atmosphere series. And in this video, as you can see, we'll be simplifying the heating of the atmosphere. So this is another subtopic, if you can call it that, under atmosphere, right? So in the previous video, guys, we did cover everything that is under the composition and the structure of the atmosphere. And I said, guys, if you really want to perform well, you have to use past papers to ensure that you practice, okay? This will help you remember concepts. This will help you to sort of expect some questions and therefore gain confidence, okay? So, as I said, guys, we did cover the importance of the atmosphere, the composition and structure of the atmosphere, all of the layers in the atmosphere, the ozone layer, the causes and effects of ozone depletion, as well as the ways to reduce ozone depletion. And as I said in this video, we will be starting a new subtopic under atmosphere, which is the heating of the atmosphere. And in this video, we'll only be covering the processes associated with the heating of the atmosphere. So this is sort of like a terminology video because we'll be looking at the terms, the fancy terms that we use here in atmospheric geography, like insolation, reflection, scattering, absorption, radiation, as well as conduction and convection. Okay, and we'll also talk about some of the terms that are not here but are related. So these are the terms that you'll be using throughout the atmosphere chapter. It's critical that you are able to define them. Okay, they'll probably in the match column A to column B question. Okay. So usually the test or the match test that you'll be writing in term 1 will have a match column A and column B type of question where you have let's say the descriptions on the right column, and then you have the terms on the left column, and then you are asked to match. So let's say you have A and then B, C, so on and so on, and then they have a definition there, and you are supposed to match what is A, match A with whatever, what corresponds with A, so on and so on. So it's important that we are able to define all of these terms, and they could actually give you a diagram, okay, which we will draw in today's lesson, and they will, let's say, replace those with A and B or C. I will tell you more about that. So without wasting any time, guys, we have to get into it, right? So we have the Earth's surface, okay, the Earth's surface right over here, which is the ground. And by the way, what did we say is the layer that is closest to the Earth's surface? What is this layer over here? Okay, we can see there's a person over there. In which or on which layer is this guy at? Okay, what is this layer, guys? Where we have the weather that is closest to the Earth's surface. We call that the troposphere, right? Okay, remember all of your layers, guys, and in order, and all of the characteristics of each layer. And I'm telling you, it's going to be asked. Now, as we all know, and as we've discussed in the previous lessons, we said that the sun releases this energy or emits. Okay, they use the word emit, that means to release. So the sun over here, it emits this energy. Okay, that energy, we called it what? We called it radiation, right? So radiation alone is simply energy that travels from one place to another. And talking actually about that, the sun releases radiation, okay? So the sun over here releases this energy, okay? And this energy is what we call radiation, right? And because it is released by the sun, we call it what? We call it the solar radiation. This is the energy that is released from the sun, guys. Okay, so that is solar radiation, energy released by the sun. Now the sun releases this energy towards Earth. Okay, so now it becomes an incoming solar radiation. Okay, so it's incoming, it's coming towards us, right? So as you can see over there, these represent the solar radiation that the sun releases towards Earth. Okay. Now, when it is incoming, okay, this solar radiation, this energy from the sun, it is coming towards us, right? We then say that it is insolation. Okay, insolation. This insolation is what we call an incoming solar radiation. It's this incoming solar energy, okay, or the approaching sun energy, right? Okay, as you can see, it is coming towards Earth. It is coming towards the surface, right? So insolation is incoming solar radiation. So this is one of the very important question, and it is a very common question in atmosphere. Okay, insolation is incoming solar radiation. In other words, insolation is approaching sun energy, okay, or energy of the sun that is coming towards us. Say that it is insolation. So, guys, you can never get this wrong. In stands for incoming, sol stands for solar, Asian stands for radiation. So insolation, incoming solar radiation. Okay. So please, we cannot forget that, right? So we're saying that we have this solar radiation that is coming in from the sun, and we say that it is insolation, incoming solar energy. Now, the atmosphere is made up of gases, right? We talked about gases. We said that most of the atmosphere is made up of which gas? We said it is made up of nitrogen. Okay, so nitrogen makes up 78% of the atmosphere. Okay, remember the atmosphere is a layer of gases. And then oxygen, it makes up 21% of the atmosphere. And then you have the 1% of the other gases, right? And by the way, talking about gases, guys, we have gases that we call variable gases. These are gases that do not stay the same amount. They change according to the conditions. So gases that do not remain the same at different times. Okay, for an example, water vapor. Okay, so water vapor is not the same throughout the year. It changes actually day by day. The amount of water vapor in the atmosphere is not the same. Okay, it depends on a lot of factors, and we'll talk about water vapor in the coming subtopics. So that is a variable gases. These are gases that keep on changing depending on the conditions in the atmosphere, right? And speaking about the condition of the atmosphere at a particular day, at a particular time, that is weather. Weather, because I was talking about the condition of the atmosphere, that is weather. Okay, so weather, the definition of weather, it is the condition of the atmosphere at a specific day and time. And we will talk about these, guys. You don't have to worry about these now. Yeah, it's just that I just keep on remembering stuff. So that is weather, that is variable gases. We're saying that the atmosphere is made up of gases, right? Okay. So now these gases can interact with this radiation. We talked about ozone, guys. Okay. We said ozone, which is made up of 3 oxygens bonded to each other. We said that ozone protects us from the UV rays. So UV rays are part of this radiation. This energy is made up of different energies like like your UV, your X-rays, your visible light, so on and so on and so on, right? And those are called your electromagnetic waves. So we said that the ozone absorbs some of that radiation. Okay, so it absorbs UV rays which are part of this radiation. Okay, remember this radiation is made up of UV rays, your X rays. Okay, this radiation that is coming from the sun, your visible light, your radio waves, and yeah, so on and so on. So some of these molecules, for an example, like ozone over here, absorb some of the rays that make up the radiation that comes from the sun. So for an example, as I said, ozone will absorb the UV ray. Okay, so they absorb it. Okay, so some of this radiation is absorbed. Okay, that's what we call absorption. Okay, we'll also talk about greenhouses which trap or absorb heat. We call this absorption. Okay, so this is when molecules entrap or take in, okay, or keep it in. They take it in, right? That's absorbing. When you absorb something, you are taking it in. You are entrapping. You are taking it, right? So when molecules entrap radiation, so that is what we call absorption. So we have this term absorption. This is when molecules entrap or take in radiation, we said. And we also talked about insolation, which is the incoming solar radiation. And this incoming solar radiation may be coming like this, right? And then it bounces back, okay? It bounces back where it came from. So it bounces back to the atmosphere or back to the outer space, okay? So this is what we then call reflection. It is reflected. It is sent back to where it originally came from. So that is what we call a reflection. So this is when radiation bounces back, or when the energy of the sun, remember that is what radiation is, solar radiation. It is the sun's energy. So the sun's energy can be absorbed, the sun's energy can bounce back. So it bounces back to the atmosphere or bounces back to outer space. Okay. And this actually depends on the object. Okay. How much is it bouncing it back? Can it reflect the sun's energy? Okay. So different objects reflect the sun's energy differently. Some objects reflect a lot of the sun's energy back to the atmosphere. Some of them reflect a little bit of the sun's energy back. Okay. And the amount of the sun's energy that is reflected back, or the measure of how an object reflects back the sun's energy, that we call albedo, guys. How much can you reflect, or how much of the sun's energy are you reflecting, or are you able to reflect? That is your albedo. That is the albedo of an object. It is a measure of how much it reflects, or it can potentially reflect the sun's energy. Okay. In other words, it's reflective power. Okay, so that is albedo, guys. Some objects have high albedo, like ice or snow, for an example, like white or bright colored buildings. Okay, if you paint your building white or a bright, or use a bright color, then that paint or that bright color is going to reflect most of the sun's rays or sun's energy back to the atmosphere. So these are some of the objects that have a high albedo. Some objects have a low albedo, and here we are talking about, for an example, forest. Okay, the forest has a relatively low albedo. The ocean has a low albedo, so on and so on. The asphalt, for an example, that we use to build our roads also has a low albedo, right? So that's what we're talking about there. So the sun's energy can be absorbed, it can be reflected. Okay, that is important to note. And another thing, guys, here that I forgot to talk about is this solar radiation. This solar radiation is also called shortwave. Shortwave radiation or solar radiation comes from the sun. Okay, that's why I made these shorter like these. Okay, they are short because they are short wave. Also call them a shortwave radiation. Shortwave radiation, that means they are high energy. Okay, intense energy. Okay, that is shortwave radiation. It is the radiation that comes from the sun. It is that solar radiation. It is that solar energy. Okay, we call it shortwave. Right? So insolation is incoming solar radiation. Absorption, this is when molecules entrap or take in this energy. Okay? Reflection, it is when the sun's energy bounces back to the atmosphere. Okay? It bounces back, it returns, it changes direction. Okay? So it immediately moves to the opposite direction. Okay? That is very important to note. It moves back to the opposite direction. It bounces. So when something bounces, if it comes from this direction, then it will bounce and then moves to the same direction it came from. That is reflection. The reason I'm emphasizing this is because we also have a term that we call scattering. The solar radiation can be scattered. What do we mean by that? So there we have the solar radiation over there. By scattered, we mean that these particles or molecules or the gases in the atmosphere, they can actually change its direction. Okay, it was coming from this side, so now it will move in all different kinds of direction. It can move that side or that side, or it's basically split into different directions. So it is scattered. So by scattering something, you are deflecting something. Say, okay, I don't know if you guys watch soccer, but when a player kicks a ball, let's say they kick a ball toward this particular player, okay, and let's say that is the poles over there. They kick this ball with full force, and this ball actually, by mistake, it changes direction. Okay, so it was going to go this direction, but because it hit the leg or a part of this player's body, it then changed direction. Okay, from its original path, it changes direction. So we say that it is deflected. Same thing happens here with scattering. Scattering, we mean that the sun's rays are deflected, or their direction actually changes to different sorts of directions. Okay, so this is deflected, or the deflection of the sun's rays. Okay, so when you think of the word scatter, guys, you think of if you have, let's say, a group of people here, right over here. Let's say this is a group of people, and then when they scatter, this guy will move over there, this guy will move over there, this guy will move over here, this one will move over there. Okay, so they move in all different sorts of directions. So that's what we mean there by scattering. We mean that the sun's energy, the radiation, is blown in different direction, if you may call it that. So some of it goes back to where it came from. Okay, for an example, like this guy over here, some of it actually still does go towards Earth, but in a different direction. It does not no longer move in that direction, but in this direction. Okay, that is scattering. But when it comes to reflection, this energy bounces back to the atmosphere. Okay, and some of it, of course, definitely does hit the Earth's surface. Okay, it is absorbed by the Earth's surface. Okay, some of it is reflected, depending on the type of surface over there, as we said. So the Earth's surface absorbs this solar radiation, even though it does not get here as full or as completely as it was when it was sent, because some of it is absorbed, some of it is reflected, some of it is scattered by the gases or the molecules of the atmosphere, and then whatever remains is absorbed by the Earth's atmosphere, right? So the Earth's atmosphere then receives this energy, converts it into heat energy. Okay, it absorbs it and converts it into heat energy, the same as when these molecules entrap or absorb radiation. Okay, so it receives or absorbs this energy. Okay, this shortwave radiation from the sun, and then over time, at night, it loses this energy. Okay, how does it lose this energy? It releases its own radiation. The earth releases its own radiation, guys. The reason why it is cold at night is because the earth is cooling off. Okay, the same way, for an example, when it is a hot day, you get hot, right? So your body temperature increases. And then over time, you cool off. What happened to that heat? Well, you released it. Okay. So your body released that heat energy. It took that heat energy off you. That's the same way that happens. Earth receives energy, which is the solar radiation, but it also releases energy, which is what we call the terrestrial radiation. So Earth releases its own energy, guys. That's why it gets cold at night, is because Earth is releasing its own energy. We call it the terrestrial radiation. It's a long wave radiation. That's why I have these waves or this energy. That's why I've drawn this energy like this. It is a long wave radiation. Okay, so when they talk about a short wave radiation, they are referring to solar radiation. Okay, the sun's energy. But when they talk about long wave radiation, then we are talking about terrestrial radiation, the energy that is released from Earth or by Earth. This is energy released by Earth. Okay, usually happens at night. Okay, and as I said, guys, we also call this long wave radiation. Okay, occurs at night. Now, what happens during the day? Okay, okay, because terrestrial radiation occurs at night. So during the day, Earth is receiving that solar radiation, right? So it absorbs that solar radiation, and then, of course, it heats up, right? So it will become hot, the Earth's surface. Okay, so it will become hot, 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 hot. So the Earth's surface is now hot. Now, what is it going to do? This energy is then going to be transferred to the molecules or to the air that is closest to the surface. Okay, the air that is closest to the surface over here will receive this heat energy. And as you can see, guys, this energy is transferred by touch because the air that is closest to the Earth's surface is in contact with the Earth's surface, right? And so we say that this energy is transferred by conduction. Conduction is a type of heat transfer, or it is a way to transfer heat by contact. Okay, so if you can imagine, if you have, let's say, a stove. Okay, say you have a stove and the stove has a plate. Okay, and then you heat up that stove, and then you place a pot on top of that plate of that stove, right? So there's the pot over there. What will happen there? The pot will heat up as well, right? Because the stove was hot, and then the stove transferred that heat to the pot on top of it because it is in contact with it. So that type of heat transfer, we call it conduction. It is the transfer of heat by touch. Okay, the transfer of heat between objects that are in contact. Okay, so that is exactly what happens after the Earth's surface receives the solar radiation. It absorbs it and then converts that to heat, and then this heat is then transferred to the gas molecules or to the air that is closest to the surface. And then that air now, because it receives energy, okay, it will get excited. Okay, you'll learn about this if you're doing physics, so on and so on. And then the air now, this hot air or this warm air, because it has gained energy, it expands and rises. Okay, we'll talk more about this. It rises up, so it carries that energy to the higher atmosphere. So it moves up and up and up and up and up. So now it transfers heat vertically like that. Okay, so that means that this warm air will now make it warm in the upper atmosphere. Okay, so it's taking this heat from the ground and moving it to higher heights. This process of transferring heat is called convection, guys. Okay, this is the transfer of heat by vertical movement of air. Okay, so that is convection. So let's not mix up conduction and convection. Conduction is the transfer of heat between two objects that are in contact. For an example, if you hold someone's hand, okay, let's say your hand is hot, warm, then you hold the hand of someone's hand that is cold, that person eventually will that person's hand will eventually get hot or warm, right? So you transferred your heat to their hand. So that is conduction, right? And then convection now speaks to the transfer of heat by air moving upwards. As air moves upwards, it is taking that heat, moving it upwards to other molecules or to the higher atmosphere. So that is convection. So please, guys, let's differentiate between those two terms over there. And yes, that is all we have actually for today. Just the terminology, which is going to be an important foundation going forward, right? So please let's continue to support the channel. Let's like, let's subscribe, let's ask our family and friends to subscribe to this channel for many, many more episodes to come, okay? So this means that we've covered the processes associated with the heating of the atmosphere. And so in the next video, we will be covering factors that affect the temperature of different places around the world. Okay. Thank you for tuning in and thanks.